Hi, everyone. Super nice to be here speaking with everyone today. Makes me super excited. Like Heather said, my name is Sara. I'm a software engineer at Microsoft Development Center here in Norway, where I work in a division called Intelligent People Services. I'm also an advocate for sustainable software engineering practices, and I'm a frequent writer on the sustainable software engineering dev blog that Microsoft have. And yes, today this is the topic: is machine learning sustainable? So when we say when we think about sustainability and machine learning, the first thing that comes to mind for a lot of people is how can we use this awesome technology for sustainability purposes? And that is a cool conversation that's worthy of having, but it's not the conversation we're having today. So today we're more focusing on what's the climate impact of sustainability? What's the carbon of machine learning? Sorry, what's the carbon footprint, if you will, of machine learning? So I'm going to go through some research and then also talk about more concrete action that you can take and hopefully spark some ideas in your head. All right, so what do we mean when we say sustainable machine learning, right? So if we put it very simple, this is what we mean. Any type of software needs to run on servers, or like a phone or a laptop or something like that. But let's just simplify and stick to servers. And these servers, they need to run on electricity. And how much they consume depend on different factors. But the more you use a server, the less it's completely off, the more electricity you use. And that electricity has to be produced. And when it is produced, it's emitting carbon or carbon dioxide equivalents. And depending on how that electricity is produced, the footprint can be high or low. For example, I am in Norway. Here we use a lot of hydro, which is a low carbon and a renewable source. So the carbon footprint or the carbon intensity is rather low. If I were to sit in, for example, Poland, which uses a lot of coal, it will be higher. The carbon intensity will be higher because it's not a renewable source and more carbon is emitted when we're using it. So when you're thinking about machine learning, there are two factors that you can operate with to help decrease your carbon footprint. First is how much resources do you actually utilize? So how much electricity do you consume? And secondly, how clean is that electricity that you are consuming? So the next obvious question that we need to ask ourselves is, how much carbon are we really talking about here? Is this a conversation that is worthwhile of our time? And I say yes. And why is that? Here is the result from a paper called Energy and Policy Consideration for Deep Learning in Natural Language Processing. And what they did here is that they trained a whole array of popular sort of off-the-shelf NLP models. And they estimated the cloud compute cost and also the carbon cost. And this is one of the results from their paper. So the first 4 bars that we see here are sort of everyday life examples of carbon emissions in CO2 equivalents, because at least I'm not used to thinking of this in numbers. It's quite hard to correlate it with something. So I think that's quite good to have a baseline. And then the last one is training of one single machine learning model, transformer in this case with neural architecture search. And as you can see, this is 5 times the footprint of an American car, which is quite a lot. Already now we can feel our pulse maybe rising a bit, like, whoa, this is a lot, right? And it is, and this is a big point of their paper, but I think it's important that we look at all of their results. So this is a wider selection. There's not, they have more good data in the paper, so definitely go read it if you're interested, but this is a wider selection than the first slide. So the section on the left is those first 4 bars. So once again, everyday life examples. And then the area here within the red box, that's the example we just saw. And now we can also see the cloud compute cost. And this is a fairly expensive query. I don't think most of us go to work and then 5 days a week we do $3 million machine learning model trainings. I mean, for some of us that may be true, but for the rest of us, we're likely, in the higher parts of that graph. So we're doing a little bit cheaper. So the green area is sort of what I think is the most interesting part. So that's how much carbon and what is the cloud compute cost. And it's still quite significant, right? If we look for BERT here, so that's fairly popular, I'd say. The amount of carbon for just training it one single time, it's still almost on par with the trans-American flight. We tend to think about like the aviation industry as quite expensive in terms of sustainability. And here, when we have them next to each other, for me at least, it was an eye-opener the first time I saw this. All right, so let's look at something else. Here's another paper, which is very interesting. And the thing I want to call to attention here is the correlation between accuracy and sustainability. So what they did in this paper is they used floating point operations as a proxy for carbon cost. So floating point operations is a metric of how much work your CPU is doing. And your CPU is a very, very energy hungry part of your laptop. So it's consuming the most energy. Also, the amount of floating point operations sort of correlate to how long you're running training. This is also only training, these graphs. So that's why they used it as a proxy. I should say that there are now a more recent paper which does some more digging, and they've said it's not the best proxy. There are other proxies like latency, which could have a more accurate result. And I've linked that in the research section, but it's still an okay proxy. So I think it's still a worthwhile paper to mention. And what this graph shows here is that this top one is the accuracy of the model, and then the middle one is floating point operation. Just think of this as like the amount of work we have to do. And what we see is that we pay a lot in how much work we do for relatively small gains in accuracy. So they both compare different models, and they also compare different layers of the same model. But the trend is sort of the same. The accuracy is like a flat line, but the floating point operations continue to increase linearly. So yeah, we are consuming more resources with accuracy, and we're also consuming more resources over time. This graph here is from a blog post called AI and Compute. And what they did here is, once again, focusing on training. They picked representative models for not every year, but for many years. And they picked sort of you could say worst in class, because these are the most resource hungry examples, but they're also the best in class because these are typically examples which have high accuracy. So like the good cutting edge research models of this year where they're plotted on. So you can see the x-axis is the years, and on the y-axis we have petaflop days, which again, you can just think of how much work are we really doing. So the really interesting part here is that there's two very distinguishable eras. So the first era, starting in the 1960s, how much work we have to do is doubling every 2 years. So that is roughly following Moore's law. So we get better hardware, and thanks to that, we are accelerating the type of queries and programs and models that we can create. And then something happened, and there's this quite steep break in that line. And we are now in what they call the modern era, so the last 10, 11 years, where the amount of work we have to do for those cutting edge models are doubling every 3.4 months. There's a quite big difference between a 2-year doubling to a 3.4 month doubling. And this is, of course, thanks to we're using more the GPU in a better way. We have parallelization in a better way. Moore's law is not really the accelerator anymore. And I think this is interesting partially because it's just interesting to know that this is how fast the field is growing. And secondly, if you're a company who depend on carbon offsets for your sustainability goals, the price of those, or the amount that you have to buy, is going to double every 3.4 months. So when you're making a budget, that can be a good thing to be aware of. All right, so that was all of the research I was planning on showing. Now let's jump into what can you do. And the first thing here is to measure your impact. So what's true for you? We saw all these great examples from the research world, which can give us like an indication, but every company, every organization is different. And these were also mostly for training. We have to think about when you do research, you want something that is sort of finite, because often when you're producing a paper, you have like a deadline. You can't have, or sometimes, but it's not necessarily feasible to have things running production over a long time. Whereas if you're a production company, that is exactly what you do. So it's important to sort of ground in your view of the world. And here I've borrowed some analogies from production engineering. So when you're building it like a thing, like a chair or a car, those engineers are very used to thinking about the full life cycle and do those estimations. That's something they learn in school, right? As software engineers, you know, the closest I've come to this argumentation is the maintainability of our code base. Like, how do you write code that's maintainable and live for a long time? We're not used to thinking about it in terms of sustainability. So that's what I'm challenging you to think about. How do you do data collection? How do you do training? Maybe you can even use some of the research results we just saw. And how are you doing inference, or how are you using your model in production? So yes, training is expensive, but even if inference is a lot less expensive per query, anything times a billion is going to be a big number. So especially if you're running code in production, that is likely the biggest cause of carbon emissions for you. And also think about the life expectancy of your solution. Is this going to last very long, or is this going to last very short? And secondly, is to measure or estimate the electricity usage and the carbon intensity. I said at the beginning, we can either decrease how much electricity we use, or we can decrease the carbon impact of the electricity we consume. That's of course simplified, but that's a good way to start thinking at least. And here I urge you to, if you're running on a cloud, ask your cloud provider, what is my electricity usage? What is my carbon intensity? Do you have these numbers, or can I file and ask to get them? If you're running on-prem, this might be easier because you likely actually get an electricity bill at the end of every month, and you can ask your electricity provider, hey, how are you producing this electricity? And I also wanted to share a tool for calculating your carbon footprint. This one assumes that you're running on the cloud, but I still think it's interesting to at least have a look at. All right, so for the second one, as you might have noticed, I like to borrow things from other disciplines and see how we can apply them. It's like a thinking experiment. And here I borrowed reduce, reuse, recycle. Once again, we're very used to thinking of this in terms of waste management. This is something that for many of us has been imprinted since we were kids, you know. We always recycle plastic bottle, for example. Of course, you should inherit clothes from your cousin, or to reuse how much clothes we buy or whatever. Can we apply this mindset to machine learning as well? So when it comes to reduce, which is well, in terms of waste management, it's a hierarchy, right? Reduce is the best, recycle is second, and reuse is second, and recycle is the third. So what can we do in terms of reduce? Well, we saw that there was a clear correlation between cost and accuracy. So how much accuracy do we actually need for this problem? If we're building an automatic or an autonomous car, well, likely we're going to need very high accuracy, right? Because it might be a life or death situation, but that's not necessarily true for all of us. So what accuracy do we actually need? The second you can reduce is your carbon intensity. And the simplest way, which you can do without changing a single line, is to plan the training of your models. So can you run them in regions which have a smaller carbon intensity? Can you run them at a different time of day, maybe when the sun is shining or the wind is blowing? There are several ways you can get this carbon intensity data. Like I said, you can ask your cloud provider. There are also or your electricity provider. There are also some open source APIs. Electricitymap.org is one example, which has really good data, at least for Europe and other parts of the world, not entirely worldwide, but it's a good start. So you can use that data to just minimize the carbon intensity. You don't even have to think about anything else, and you still get a significant cut in your emissions. Secondly, if you're running on-prem, you likely have a lot of hardware. You're maybe not using that hardware all the time, and hardware is consuming electricity even when it's idle. So moving to the cloud can have a lot of benefits in that sort of category. And then once again, I want to stress, what does your cloud provider provide you with, and just have that conversation. Cloud providers, we are there for our customers. So definitely it's worth having that conversation. Secondly is to reuse other people's models, and not only necessarily models, but also thinking about the data collection. Can you use data from an open source? And also, can you pay forward? Can you make your own models and your own data open source and help the community at large? And lastly, can you recycle your ML and AI solutions for a new problem? This one may seem a bit tricky, but I really want to challenge your thinking here. And is this possible, and in what way, and how can we have this conversation? Just start to think about something in a new light can sometimes shine perspectives on new solutions. All right, so that was all I was going to say. I have some resources here. They're also shared in the meetup, so you can go there and see them as well.
Amazing. Thank you, Sarah. So open up for, I guess, about 5 to 10 minutes of Q&A, and then we can jump into discussion. Any questions that you're comfortable sharing on recording, please jump in and ask them now. If you want me to read them, pop them in the chat. Do you know if AWS, Google Cloud, or Azure have tools that help with green computing?
Right, so this is the part where I once again stress that I work for Microsoft, which is important to disclose. So I don't know about AWS or Google, but I do know that Azure has the sustainability calculator, which I think is very cool and interesting, which is something you should check out if you are running on Azure. In terms of concrete planning of models, not sure if there is anything good right now, but yeah. I think all cloud providers are going to realize that this is something that partners or customers want. So hopefully we'll see a lot more of these sort of things in the future.
One from Abhishek. Do you know what the rates of adoption of tools like MLCO2 calculator have been so far?
Unfortunately, I don't. I don't own it or know who owns it. But I really hope this is a conversation that is starting to take flight. But no, I don't know yet. I just know that there are a lot. If you would just look at research, right? Research is usually a good indication of what people are interested in and what's going to happen. And there are a lot more papers being published now on this topic than there was just 2-3 years ago. Then the papers that were published were very, very focused on data centers, right? How can we build an efficient data center and that sort of thing? And now the focus is shifting. So I really think this is something that we're going to hear and see a lot more about.
Cool. Why would you recommend clouds over local systems? In a local system, I can attach a wattage meter and know exactly what I use, and also choose my energy provider that for example, uses only solar power. Isn't that better than a cloud?
Exactly, that's a good point. And yes, when you're running on-prem, you get more of that sort of control. Many cloud providers have sort of hybrid models as well, so you can actually like own your own data center, that sort of thing. But that isn't necessarily feasible for all organizations. But yes, what you get from also running in the cloud is that they have an overall strategy for hardware. Buying hardware, and they also make sure that hardware is utilized at a proper rate. So when we think about energy proportionality, a server that's just on is going to consume resources. If you just have it standing in your basement or in your server hall, it's going to consume resources. And a lot of especially when you're running serverless, then you allow someone else to completely plan that scheduling for you. So how to shift workloads, how to make sure we're running, excuse me, a service at a higher utilization rate. That means we're essentially getting more computation for the same energy. Because as I said, we have a baseline, and if you utilize the server more, the electricity consumption isn't linear. And those sort of benefits, you can of course get them if you do all of this on your own, but it's a little bit easier to get that from the cloud. Also, many cloud providers nowadays, they have very strong connections to the local or regional or whatever electricity providers. So a lot of them are now pledging to I can only take Azure for example, which has been carbon neutral since 2012, and they're matched by renewables. That can be harder if you are a smaller independent organization to get that conversation going, but it's not one size fits all.
That's really helpful. Thank you. And if you have any follow-ups to your questions, please pop them in. Next question, would carbon pricing help to make machine learning greener without losing on model performance?
Right, so with carbon pricing, I'm not sure exactly what you mean, but I'm guessing it's like if the cloud provider charge you for the amount of carbon. Maybe we can ask for clarification.
Yes, I can clarify. So carbon pricing in general means if you have to use sort of fossil fuels or produce carbon, then your price. So basically, the electricity goes up. So that's one thing, but it's not just the electricity of your own products. It's also everything around you. So the laptops become more expensive. Your supercomputing becomes more expensive. Maintenance becomes more expensive. All these kind of things.
Thanks for expanding. Yes, for sure. I think that's a good idea, especially. So there are two parts here, right? Like I said, how much resources are we using, and how clean is the energy? And if we introduce carbon pricing, yes, it will definitely be a way to shift workloads and organizations and people to greener resources. But I believe, especially if we look at like model growth, it's only one side of the problem, and we can accomplish a lot by doing that. But if we're not also tackling our growth issue, there's only a finite amount of energy produced right now. We also need to, like, of course, in a perfect world, there are more and more green energy options coming all the time, and this will sort of regulate itself. Right now, we still know that a lot of parts of the world is running on non-green energy, and just moving all of their computation to greener region I don't believe it's the full solution to the problem, but I believe it's a part of the solution. Yes.
Thanks.
Thank you.
You're on mute. Okay. What's been the most significant change you've seen in the research on the environmental impact of AI over the past 2 years?
Oh yeah, so that's a good one. So I think first and foremost that we're starting to have this conversation. The paper I showed in the beginning, it was very instrumental. It has a lot of citations, and now people are getting more interested. Secondly, I think the sort of hunt for a good proxy, because while it's very interesting to get that concrete number of CO2, that's in the end what we all want. But finding what is a good proxy, how can you? Because in the end, if that's what you need, you sort of need to run the models first and then look at, okay, how much did we consume? We want to know before, right? I want to be able to say, okay, this is going to be expensive or this is not going to be expensive. So finding a good proxy for how do we measure carbon through a proxy like latency, like floating point operations, and what part of the stage of the pipeline can we do this? I think that's an interesting conversation, and I think a lot of papers are centered like on how can we model this and how can we measure and what's the metrics we're going to use. So I'm very excited to see the next 1, 2, 3 years where we're going to what's going to become the industry standard.
Great, it's very exciting field. The next question, are there any energy or carbon related metrics that you would recommend to include on model cards?
Yes, also good question that really ties into what we just talked about. So a lot of papers are using floating point operations, which is quite good because it's also sort of agnostic to your underlying architecture and stuff like that. So that's really good. Or some people are saying it's really good. And then also actually latency is a good metric. Like how long did it take to run this experiment or this training? Because the longer something is on, the longer it consumes resources. So that's also a good metric, I believe. And then if you have the opportunity to actually measure the electricity usage, that's great. But yeah, it like I said, I think there could be potentially even more things we could look at here, but we just don't know yet, or no one has vocalized their idea yet. So something I definitely hope people will discuss in the breakout rooms.
Yes, definitely. Speaking of those, I'll take the next 2 questions and then we can jump into breakout rooms. I'll also take these questions and pop them into Slack so we can continue the discourse over there in Thread. So next question, how can we put additional pressure on cloud computing systems to make sure green renewable electricity is used?
Good question. And yes, this is, I think almost all major cloud providers have some sort of sustainability goal, which they launched rather recently. A lot of companies came last year with these very ambitious goals. And I think if you are a customer, you should definitely ask your provider, because cloud providers are there for our customers. And if our customers want something, then that's what we should build. That's how economy works. So definitely worth having that conversation. If you're not satisfied with the answer, ask to talk with someone else. Because yeah, we're here to help, and we're in this together. It's not. I think this is one of those rare things where we're actually all on the same side. We're just gonna have to find a way to get there together and do the best of the situation. So yeah, put pressure on them for sure. Yeah. And also, if you're on-prem route, you can right now you can also shop around, right, and ask the different ones. Oh, I obviously will advocate for one of them, but I'm not going to do it.
Okay, last question, then we'll jump to discussions. With the slew of upcoming dedicated training accelerators, Habana, Sabanova, GraphCore, make ML training more sustainable?
I hope so. But that's also, for some, yes. Especially if training is the most expensive part of what you're doing. But for production companies which has like bigger products, with a lot of users, then likely training is not your biggest cost. It's likely the inference part of running those predictions in prod that is the biggest part. And then yeah, the training might be expensive, but in the end it will be eclipsed by the other number anyway. So that's why it's important for you to look at end-to-end, also include data collection. Data collection can be done in so many ways, so it's kind of hard to at least find any research resources on that, but it's yeah, you know best how you do data collection, and if that is done in like an expensive way, yeah, there are many parts to this, right? But I think it's a very interesting trend for sure.
Thank you so much, Sarah. We have another one, but I'll leave it for the discourse. Really thank you for taking all those questions. Just kind of threw you into the deep end, but there's some really good questions. So I'm going to stop recording now. We'll share the link out to everyone shortly. And I think I might have to start an AI and ML channel within Slack, so look out for that, and I'll invite you all. So.